Alright. We'll play Anton for a little while. This is a pretty cool, little theme park to come right around in. I'll toss him as he's going.
Hello wonderful person, this is Anton, and today we're going to be talking about a discovery coming out of a very strange cluster that orbits our own galaxy. A star cluster known as Palomar 5, with orbit visible in this picture right here. And what makes this cluster extremely unusual compared to everything else we've discovered is that it seems to possess a tremendous amount of black holes on the inside, at least 100 and possibly a lot more. And so let's talk a little bit more about this unusual discovery and what exactly
normally
this
if it wasn't
means,
Anton,
and discuss these clusters in general.
Or.
First of all, our galaxy has roughly around 150 different globular clusters around it. Without exception, all of these clusters are extremely old, usually at least 10 billion years old, meaning that many of them were produced when the galaxy was just being created.
Types of galaxies,
and generally
by their
speaking,
element.
we can usually use these globular clusters to measure the age of different
well, you
galaxies
could say
as well.
the shell
While at the same time
and the
also
nucleus,
discovering some of the
made
details
holes.
of various galactic collisions that happen to Milky Way and to some of the nearby galaxies as well. But generally speaking, star clusters and globular clusters sort of look like this. But some of them, over time, because of the gravitational interactions with the Milky Way, or possibly interactions with the mysterious dark matter that's located all over the halo of the galaxy, some of these clusters over time start to kind of stretch and experience tidal disruption. With this illustration right here roughly showing us how all of this happens. So after about 1 billion years, a typical globular cluster will generally start to acquire two different tidal tails on both sides. And as it orbits around the galaxy, the tails eventually stretch, forming very beautiful formations, which within only about 5 billion years create something that looks like this. And in the past decade or so, we've discovered quite a lot of these formations because of the advancements in various telescope technologies. And today we refer to these formations as stellar streams. This one right here was discovered back in 2007. But some of these streams are also formed by different galaxies, specifically dwarf galaxies. And this is kind of what the scientists believed Palomar 5 to be at first as well. Over time they realized that it was just too small and not massive enough. And with further measurements they realized that this was basically a globular cluster you see right here that's being tidally stripped apart by the powerful gravitational forces from the Milky Way galaxy. But there are a lot of features that make Palomar 5 kind of unique and different from other clusters. First of all, it's about 10 times less massive than other clusters, and it's at least 5 times longer than a typical globular cluster we're familiar with, making this a cluster that's about to become a stellar stream. It's not one yet, but it's definitely going to be one.
So it's
and
a
all of
ring
the
like
observations coming from this cluster do suggest that what you're looking at right here, these are stars escaping the cluster itself, with the stream itself already being about 5,000 masses of the sun.
That's what's so hard about
approximately
chemistry and a bunch of other stuff
30,000
too.
long.
You know, the glass works.
If you wake up
Chemistry
worrying,
is glass blowing
am I
and
going to get
physics and
evicted?
plasticity and just figuring
Am I
out what
going
those
to have
elements,
enough
because
money
that's
for
the
my
limit of the
utility
matrix.
bills?
But you could put
COVID-19
different
really set me
solutions
back.
with different
You
solutions.
wonder
and
every day,
pull out
how can I
Oshiriga,
hold it
Chrono
all
Solution,
together?
or Ben Eater,
Help is
Eater
here.
Feed and CERN.
You may
Which is
CERN
slightly
being
longer than the
everybody.
distance of the center of the galaxy to planet Earth that you see right there. Now the cluster itself is right here, about 60,000 light years away from the
So we just
galactic
got done with an
center.
SCP about
But since it only
spacefaring.
recently
I think
started to
it's like
become flattened and
2014,
stretched by the
43 or something like
gravitational
that,
forces, it
It's all
implies
about
that either
space
A, it
oddity
was
over there
captured
for
relatively recently by the Milky Way,
Loiter,
or B, it was in a very different orbit around the
Explorer
Milky Way
Series
galaxy.
version
So in
of the
other words,
galaxy,
something might have
this
actually
galaxy.
changed its orbit,
I've seen
causing
this
it now
before, the
to
Corgi.
fall through the Milky Way galaxy and thus becoming tidally disrupted.
And
But
then
unlike
buried
other
in
clusters
here.
and unlike other tidal streams, what makes Palomar 5 extremely unusual is an extremely high number of black holes located on
a
the
big one.
inside. About 20% of the entire mass of the cluster is basically black holes.
Yeah, what is
With
it?
most black holes
Arcane.
being about 20 masses of the sun or more, and at least 100 of them present somewhere in the center of the cluster itself. And since it's believed that all of them were produced by exploding very massive stars billions and billions of years ago, it's not entirely clear why this particular cluster seems to have way more black holes than any other cluster we've found so far, with potentially one explanation being that maybe there were just a lot of really massive stars to begin with. Maybe initially this cluster just had a lot of different stars that
Like,
turn
I'm
into
talking
all
to
of
you,
these
like-
black holes with an average mass of a star just being higher than in other clusters. But there are a few more things that make Palomar 5 really unusual. Now, first of all, this is so far the only cluster directly associated with a stellar stream. Other stellar streams already sort of existed, but we don't really know which cluster might have actually formed them. And so because of this, Palomar 5 might explain a lot of things about stellar stream formation, while also helping us understand what happens to globular clusters when they're tidally disrupted by various galaxies. The other unusual discovery about the cluster is, of course, in regards to its future, which sort of relates to the explanation of how this is possible. So first of all, a lot of this was based on trying to simulate various orbits while changing various parameters in the cluster until the scientists found a good match between the observations and between the theoretical predictions. And the simulations here suggest that the cluster very likely started like this. But over time, because stars were more likely to escape the cluster than the black holes, the number of black holes started to increase, yet the number of stars started to decrease. While at the same time, because there were more and more black holes in the center of the cluster, the gravitational interactions between stars and these black holes forced a lot of these stars to move to the outer parts of the cluster or to eventually escape completely. And as more and more stars started to escape from the center and to develop this stream that we see right here, the only things that were sort of staying on the inside were hundreds and hundreds of different types of black holes. And as more black holes appeared, more stars would disappear with time, eventually turning this place into a collection of black holes and no stars whatsoever. But because of this unusual discovery, the scientists also imply that many such dissolved clusters probably already exist around the Milky Way galaxy. But unlike a typical globular cluster, these would be dominated by just black holes and maybe some neutron stars, but mostly black holes. They would also be almost impossible to detect, with the only potential sign of their existence being some leftovers of ancient stellar streams that might be discovered in some of the future studies. But this also might help the scientists answer the questions about other stellar streams that are orbiting the galaxy right now. The origin of some of them is not really well known yet. More importantly, this also helps us understand, or helps us realize, that a lot of different black hole collisions, especially the ones we've been detecting in the last few years, might also be coming from these globular clusters that would be otherwise invisible to most telescopes. So the large population of black holes in this case does actually imply that there's a high chance of collision between them at some point in the future. But since we can't really see black holes, and since we can't really discover them in any other way, it's almost impossible for us to figure out how many such clusters exist already, and also how many black holes are there to begin with. Now, the simulation here implies that it's maybe over 100, but that's just a simulation. In reality, we don't actually know. Nobody has any idea on how to measure the amount of black holes in these clusters. But in this study, the scientists do use a mathematical analysis and sort of find a way to maybe estimate the number of black holes by just looking at how many stars are being ejected from the cluster compared to the ones that stay in. And so in that sense, it is a pretty interesting analysis and a pretty interesting study. But unfortunately, there's not much else we know about either the cluster or the black holes in this cluster. Once we find something else unusual about it, or some other unusual cluster out there, I'll make sure to follow this up with another video. Until then, thank you for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something else. Maybe